If you can solve this paper in 30 to 45 minutes, definitely you can get good marks in JEE Advanced paper 2. Okay, so this session covers the paper 2 model of questions. The first question is asking a metal exists in BCC structure. The uncovered distance between the atoms along the edge is equal to 67 picometer. Then the distance of the crystals we have to find. Okay, so uncovered distance means what we can do. First, we know edge covered by the atom, right? The fraction of edge covered by atom, which is for a BCC structure, which is equal to 2R by A. They are asking about uncovered. So what we can do? 1 minus 2R by A. So 1 minus 2. For this value, we know that root 3 by 4, which is equal to 0.134. Correct? Okay. So how we can find the A value? So 0.134A, which is equal to 67 picometer. So A is equal to 67 by 0.134, correct? So which is equal to 500 picometer. So we found A. So the next thing we are going to do, which is we are going to find our density. So what is the formula for density? Which is very simple. We've already practiced more question on that. D is equal to Z m Avogadro number into V, volume. So 2 into, for BCC I took 2, 75. They have given the atomic mass as 75, and Na, which is 6 into 10 to the power 23. That's what given over there. Volume we found that is 500 picometer. So AQ, that becomes 500 into 10 to the power minus 10. I'm just going to convert it to meters. So 10 to the power minus 10. So the answer comes out to be 2 gram per centimeter cube. Okay. So that is our density value. Clear? Moving on to the next question. In the reaction sequence given below is carried out with 1 mole of the reactant and the amount of product S formed in grams. Okay, so reaction is very simple, isn't it? So what is the reaction? Just we'll think about that. So here I have 1, 2, 3, 4. 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbon. Fourth carbon I'm having, which is a carboxylic acid group. So with the reaction of SOCl2, what that will do? It will become our 1, 2, 3 COCl. Correct. Then that is our Q, followed by the reaction of AlCl3. So AlCl3 we very well know that is having a vacant orbital which can accept the lone pair, which is a Lewis acid. So accept the lone pair, it will accept the Cl. So this position becomes plus. So it will lead to the formation of ring over here. So 1, 2, 3. 1, 2, 3. In fourth carbon, I'm having COCl. CO. Right? So that is our R. So followed by the reaction of zinc amalgam. What is this reaction? If you know, comment it and put it in the comment section. As a reward, I will give you the mock test question paper. The whole full syllabus of physics, chemistry, math, mock test paper. Okay? Right. So what is this reaction? Is zinc amalgam with HCl. So what that will do? That will give you the reduction of formation of CO group to just a CH2. Okay, that is what our S is. Okay, so what they are asking, the amount of product S formed. So 1 mole we took as SP. So 1 mole got reduced to 50%, which is 0.5 mole, and from 0.5 it became 80% of that. What is 80% of 0.5? That is 0.4 mole, isn't it? So S is whole 100%. So 0.4 mole of S we are going to find. So molecular weight of S, which will comes out to be, let me check. Okay, so I'm writing it here. Molecular weight of S, which is comes out to be 132, right? So 132 into 0.4, which is equal to 52.8. So the nearest integer would be 53 as your answer. Okay, very simple question, isn't it? Then consider all the esters of molecular formula C7H14O2, including the stereoisomers. They are all treated with an excess of methyl magnesium iodide. Okay, and then acidified with to give alcohols. Fine. Each ester produces 2 different alcohols, excluding stereoisomers. Great. Both of which react with BrNaOH to form bromoform. So what is the criteria to give bromoform? That is the main clue point of this question. What is the criteria? It should have a CH3 group attached with the functional group. Right. So the free CH3 group you should have, which should be attached with the functional group. Then only it will give positive for bromoform reaction. So what kind of ester we can take? That is our question. So the ester must be a formate ester. That is point number 1. Why we have to take formate ester, ma'am? So I can take a methyl ester. So why I shouldn't take any methyl esters? Because methyl magnesium iodide is giving a reaction in between. So the methyl group will get attached anyway to the ester carbon. So when form the alcohol followed by the bromoform test, that methyl will give you the positive. If I am having an additional methyl group, that will lead to tertiary or quaternary tertiary alcohol. Correct? So I don't want that to happen. That's why I am taking formate esters. That is point number 1. Then what type it can include? I am writing what are the esters it can give. The first one which I would like to take, the formula is C7H14O. So 1, 2, 3, 4, 5, 6, and this is one ester. Okay, here I am having O, COO, H, and then another type would be, again I am taking a formate ester. I told you why. This side only you can play with these molecules. Okay, this is another type. The another possibility for formate ester for this formula would be, you can substitute it in the alternate position. Right, one is here, another one you can have it here. Right, 1, 2, 3, 4, 5, 6. Great. Then another possibility would be substituted on the same carbon. Correct. So having like this. So 1, 2, 3, 4, 5, 6. Okay. This side I'm having hydrogen. So these 4 esters, you already know what are those reactions will happen for these esters. Okay, that will form a methyl group will get attached to over here for each of these CO, and then it will become a OH. So that's what is going to happen, that those alcohols will give you the bromoform test. So answer to this question is 4. Then the next question, at 143 Kelvin, the reaction of XeF4 with O2F2 produces a xenon compound. Why? Okay. Total number of lone pair of electron present in the whole molecule. Okay. Present in the whole molecule they are asking. So if you are taking the bond pair and lone pair of this formation of XeF6, you may not get it anytime. But the question they are asking for total number of lone pair of electrons present in the whole molecule. You can see xenon is having the lone pair, right? And then fluorine, which will have 3 lone pairs each for each of these fluorine. So 6 into 3, which is 18, plus 1 xenon lone pair, total 19 lone pairs are there. Here comes another lengthy question. 1 mole of monoatomic gas is involved in the cyclic process as shown in the PV graph. Okay, great. The extension of the line segments 1, 2 and 3, 4 passes through the origin. The curves 1, 4 and 2, 3 are isotherms. What is isotherm? Temperature is not changing, is it? So find the ratio of V3 by V2 if V2 by V1 is equal to 2. Okay. So first what we have to do, what we already know, V2 by V1 which is equal to 2. So that's what we know already. So from that part, I'm going to take a lead of 0.1 and 2. First I'm going to take 0.1 and 2. Right? So P1, V1 which is equal to P2 by V2. Correct? Okay. So we have given that V2 by V1 is equal to 2. So which means V2 is equal to 2V1. So in that case, P2 will obviously become P1 V2 by V1. So it will become 2P1. Isn't it? Because V2 by V1 is equal to 2. Or otherwise, I can say P2 by P1 which is equal to 2. So that is the value I got. Next, 2 to 3, which is again an isotherm they have mentioned. So that is isotherm. Fine. So P2 V2 which is equal to P3 V3. So just to look at the curve over here, 2 and 3 I am talking about. Okay. Then, so which means that 2P1, I am going to substitute these values. 2V1 equal to P3V3. That will give you 4P1V1 equal to P3V3. Right? Then I am moving to 4. 1 to 4. There I will find P1V1 equal to P4V4. I'm checking like that. So I'm actually having that as an equation 2. Earlier I found equation 1. Then 3 to 4. What is 3 to 4? This curve. 3 to 4. But 3 to 4 I have which is passing through the origin, right? 1 to 2 and 3 to 4 is passing through the origin. Then in that case I am having P3, V3, P4, V4, which will give you P4 as P3 V4 by V3, right? Now why I have to take P4? We are going to substitute equation 2 here. So while substituting that P4 in equation 2, P1 V1 equal to P3. Instead of P4 I am substituting it. So V4 by V3, that is what the P4 value is, once again P4, which will give you P3 V4 square by V3. So that I am keeping that as equation 3. So then what I am left with? 1 to 3. Correct? 2 to 3 done, 1 to 4 done, 1 to 3 I am doing. So P3 V3 equal to 4 P1 V1. So that's what I found in the earlier one. Correct? 1 to 3. So in that case P3 becomes 4 P1 V1 by V3. So I am substituting equation 3, which is the value of P1 V1 over here. While doing that, P1 V1 V3 into V4 2 square by V3, that will give you 4 P1 V1 V4 square V3 square, right? Okay. So in that case, so whole P1 part will get cancelled out. Remaining 1 is equal to 4 V2 V4 square by V3 square, which is equal to V3 by V4 equal to 2 I am getting. By solving this equation I am getting 2, which means that V3 by V2 4V1 by 2V1, which is equal to 2. That gives me V3 by V2 equal to 2. Okay, the equation is V3 by V2, which is equal to 2 as your answer. So the question is simple. The formula also we already know, it's bit lengthy, that's it. Okay, save your time for this type of lengthy questions. Okay, moving on to the next question. If X is the number of moles of compounds which on strong heating gives the oxygen as a product, then find the value of X by 2. Okay, so on strong heating it should give oxygens. So here all of these I am having oxygen. You can see all these can give oxygen as the product. So 1, 2, 3, 4, 5, 6, 7. 7 is number of compounds product. Then find the value of X by 2, which is 3.5. This question is match the column type of question. Aniline, orthocresol, cysteine and caprolactam is given. We have to match it with the correct test. So the questions are, which of the following is only correct combination and incorrect combination or questions. Okay, so let's check what we have here. The first thing, which is aniline. aniline will look like, which is having a nitrogen group in it, which is a base. So sodium fusion extract of the compound on boiling with FeSO4 followed by the acidification of concentrated H2SO4 gives Prussian blue color. So which is good because nitrogen group is confirmed by this test, sodium fusion extract, right? So P 1 to P is right. Then orthoprazole. Orthoprazole will have a OH group in it along with CH3 in the benzene ring. So let's see. So orthoprazole will give an answer for neutral ferric chloride test because of the presence of phenol group, right? So 2 to T is correct. Then cysteine, which is amino acid, 2COOH, SH will look like. So sulfur and nitrogen are there. So which will give you what test? Gives blood red color with FeCl3, 3 to Q. Then 4, caprolactam, which is in nylon 6 monomer, right? The reactant that is having a nitrogen in it. So which will give you P. So 4 to P. So let's check the options given for correct combination. 1 to P and Q. P that can give not Q. Then 2 to S. No. 3 to Q and S. 4 to P. So 4 to P that can give. So answer to this question is D. Next we are going to find the incorrect combination. So 1 to P, which is correct, right? We already know. And Q, second one to R and T. R, which is an sodium bicarbonate effervescence, and T, that is treated with neutral ferric chloride solution, shows violet color. So R can't be possible. Will not show effervescence for orthoprazole. Orthoprazole will not give effervescence, and T is right. But still orthoprazole will not give, so it can be our answer. And 3 to Q, that is right. 4 to P, that is also right. So option B is our right answer. Then from TS diagram available of a Carnot cycle engine. Okay. Heat gained by this sink in kilojoule per cycle. We have to match this list. So for that we have to do the calculation to find out the values, isn't it? So let's do the calculation. They are asking for the Carnot cycle efficiency, right? So eta, which is 1 minus T1 by T2. I'm going to substitute the values. 1 minus 0.5 because temperature got decreased by 800 to 400. So 0.5, which is equal to 0.5. Efficiency is 50%. So Q total, that is Q total plus W. So Q will be minus W, isn't it? So Q equal to T delta S. So T2 delta S minus T1 delta S I'm taking. So T2 is a heat taken from the source and T1, which is heat rejected to the sink. So I'm substituting the value over here. 800 into delta S. So delta will be 400 minus 500, right? So here I'm having 400 and 500, so which will be 100 minus, once again, the T1 value, which is 400 into delta S, that is 100. So the answer becomes 80,000 minus 40,000, which is 40,000. So Q total, which is 40,000, which is nothing but 40 kilojoule. Correct? So delta, work done, which will become minus W, which is equal to 40 kilojoule. So heat rejected to the sink is 40 kilojoule. So the number of cycles required to illuminate how many bulbs? Number of cycles required to illuminate 100 bulbs of 200 watt each. Okay. So 100 or 1000 bulbs. Okay. So 1000 bulbs of 200 watt each per second they are asking. So 1000 into 200 divided by our value of W, which is 40,000, equal to 5. Right? So let's match with the values. Heat gained by the sink. Gained by the sink, that is P. Okay. Then work done per cycle, which is equal to W, modulus of W, which is 40. Efficiency, that is 50%, and the number of cycle required to illuminate 1000 bulbs, that is 5. So let's check with the correct combination. 1 to S, 2 to P, 1 to not S, 2 to P, is it right? Yes, that is right. 2 to P, is it right? Then comes 3 to Q, 3 to not Q, it is S, 4 to S. 4 to S is also not right. So answer to this question is 2 to P. And talking about the incorrect combination, let me write the correct combination first. So which is 1 to R, right? 2 to P, 3 to S, and 4 to Q. So 1R, 2P, 3S, 3S can't be our answer, 1R can't be our answer, 4Q, that also can't be our answer. So answer to this question is 2R. Okay. Then next question, which is from organic part, your favorite part. So CH3 to followed undergoing oxidation with Ka1O4, forming A, and then ammonia plus heat. Percentage of nitrogen in B is 17, followed by Br2 in basic medium, C, and then major, that is major. Then 1 mole of C I am taking with 2 moles of ketone or carbonyl compound to give D. So D formula is C18H20N2. So what is the question asked? So which of the following, let me tell you the question first. So the question is correct options from the following. Select the correct options from the following. They are concerned about B, C, and there are 3 aromatic rings in the D, and number of electrons in D is 7. Okay. All A, B, C, D we have to find. Correct. So first thing first, what will happen when CH3 on benzene ring is undergoing oxidation with K1O4. So it will become COOH group, isn't it? So COOH, COOH. So whatever the chain may be, it will become one carboxylic acid group, that is our A. Then NH3 with heat, that would produce amides. Very simple. CONH2, CONH2. Then bromine. Amide with bromine, what is that reaction? Put it in the comments. I will give you the mock test paper with solution, guys. Okay, so what is this reaction? That is our question. Okay, moving on to C, which will give you amines, isn't it? Amines. Then C is reacted with, amines are reacted with this carbonyl compound. So what that will give? So I'm writing it over here. Amine with this 2 mole of this carbonyl compound which will give you each one of this carbonyl part will get attached to the amine part. Before that, it will undergo a ring formation. So the product would be benzene ring with N, that will be a ring formation. Right? Ethyl. Can you imagine? That will form a ring over here. And another side also repeats the same. So that is our D. Okay. So with the formula C18H20N2. Great. So which of the following is correct? Our B is not this. So this is not our answer. What about C? This is our C. This is correct. There are 3 aromatic rings in D. That is it true? All are aromatic rings? Is it all are aromatic rings? Yes. 1, 2, 3 aromatic rings are there in D. Number of pi electrons in D are 7. Pi electrons 1, 2, 3, 4, 5, 6, 7. That is also right. So answer to this question is B, C and D. This question, the normal boiling point of delta H vaporization of liquid X are 400 Kelvin and 40 kilojoule per mole. Assuming delta H vaporization to be constant over the given range of pressure, which of the following is correct? Okay, this is more than one correct type of question. So first, let's find out delta S value, because in the options you can see they are asking for delta S value for the given temperature and the pressure changes. Okay, so let's find out delta S. Delta S, which is equal to delta H by T. Right. So for the given boiling point, delta H, which is 40 kilojoule, I am taking that as 40,000 divided by 400, which I am getting as 100 joule per mole Kelvin. Okay, 100 is right. But what will happen if the pressure changes? Let's say the pressure is 0.5. If the vapor pressure, the pressure of the external is decreasing, what will happen? The TB, the boiling point temperature, will be less than 400 Kelvin. Correct? So which will lead to delta S as more than 100 joule per Kelvin per mole, right? It is inversely proportional. So delta S is more than 100 if 0.5. So option A is right. Then moving on to option B is 1 atm. 1 atm will not change. That's what we have took over here. So that is not our answer. Then option C, 2 atm. It's just a reverse. The way pressure increases means the temperature, the boiling point temperature will also increase. So delta S will get decreased. So this is also our answer. What about D, which is equal to 1 atm means that will equal to 100. So that can also be our answer. So A, C, D are our answer. Then consider the following column chromatography. They are asking for the incorrect options. So the alumina can be used as a stationary phase. First of all, let's see what happened in the column. A, B, C are the three bands for the components to be separated, and a mobile phase and stationary phase are given. So first option, alumina can be used as a stationary phase. That is right. Alumina is a good common absorbent which can be used as a stationary phase in column chromatography. So which can't be our answer. Then component C is strongly adsorbed. Component on the stationary phase. Component C is very low. So which means that the statement is incorrect. Component C is actually at the bottom of the column, right? The lowest point, meaning it has moved the furthest through the column. The components that move further, the second option says the component C is strongly adsorbed component on the stationary phase. C is in the bottom. So which is not strongly absorbed, which is a weak absorbent, weakly absorbed component in the stationary phase, right? So this can be our answer, and physics option of the components occurs on mobile phase. So physics option means occurs on the stationary phase, not on the mobile phase. The mobile phase carries the component through the column, but not it will not absorb them, isn't it? So which can be our answer, and chemistry option occurs on stationary phase. And once again, it relies on the physics option only, the whole chromatography, which is weak and reversible rather than chemistry option. So chemistry option involves the formation of chemical bonds between the absorbate and the surface. So which can't be which is not a correct statement, which can be our answer. B, C, D are our answer. Then acid A is prepared from white phosphorus on the reaction with alkali followed by the acidification, while acid B is prepared from red phosphorus on the reaction with alkali followed by acidification. Select the correct combinations. Okay. So acid A is prepared from white phosphorus with alkali. So white phosphorus with alkali, which will give you H3PO2, isn't it? So what is the structure of H3PO2? H. And if I am treating red phosphorus with alkali, which will give you H4P2O6, right? So the structure of H2P2O6, which will look like OH on one side followed by P and another OH remaining, right? So let's take the options as well. Oxidation number of phosphorus of acid 1. So oxidation number of phosphorus, what is the oxidation state? It is 1, right? And then acid B that is 1, 2, O, O, minus 1. So which will be 4. Okay. This can be our answer. And then number of POH bonds in a molecule. Acid A is 1 and acid B, that is in one molecule they are asking, that is 4. Okay. That can be our answer. Number of pH bonds in one molecule. pH bonds are 2. Okay. pH bonds are not there. And the last one, number of PO bond in one molecule. P double bond O, that is 1. P double bond O, that is 2. So A, B, C, C, D, all 4 is our answer. Then in a pair of isomers, the molecular formula C5H8, both the compounds undergo catalytic hydrogenation to form a compound of molecular formula C5H10. Okay. On ozonolysis followed by oxidative workup, one of those isomers gives diacid C5H8O4, while other isomer gives keto acid C5H8O3. The pair which gives the above test of the reactions are. Okay. So in this case, we are looking for a compound which are having an ozonolysis, one isomer followed by workup, one of those isomer give diacid. Okay, so which is, let's do the structure of these compounds. 3-ethyl cyclopropene. So cyclopropene and 1, 2, 3 I am having ethyl, right? And then 1 pentene. 1, 2, 3, 4, 5. 2, 3, 4, 5. And then 1 pentene. Okay. Then option B, cyclopentene. Cyclopentene and 1 methyl cyclobutene. Cyclobutene. Then 3 methyl cyclobutene. Cyclobutene. 2, 3. 1 methyl cyclobutene. 1 methyl cyclobutene. Okay. 2 methyl cyclopropene. 1, 2 dimethyl cyclopropene. 3 methyl cyclobutene. Okay. So let's check, just analyze with the formula given. So one is giving C5H8O4. The another isomer gives the keto acid C5H8O3. If you could see the clue point over here, that is given that one isomer gives diacid, the another isomer gives keto acid. So if I that want to give a keto acid, which means that the double bond should have the double bond attached with some other substituent group. So out of this, which is having the double bond attached with the substituent group? So can I take option B and C? You can take D also, but this will not give you the keto acid, right? So that can give you the keto group, that not the acid. So B and C, that can give the keto acids, right? So let's see, let me write the reactions also. Let me take B, cyclopentene. On ozonolysis, what that will give? The double bond will break. Put double bond O. They are saying that this giving undergoing the oxidative ozonolysis. So which will give you carboxylic acid. And the another compound that is having like this. So upon oxidation, put double bond O, and here I am having COH group. So this is keto acid and this is diacid. Similarly, I am taking option C. So option C, like this, on ozonolysis, which will give you the carboxylic acid COOH, and this side also COOH. Here I am having substitution, and then another pair that is with the same as this one. Okay, so that can give you our keto acid. So answer to this question, which is option B and C. Then moving on to the next question. This is undergoing again the ozonolysis. Without ozonolysis, you can't find any paper, any competitive examination paper. So it is undergoing ozonolysis to give A, and A is treated with hydrazine to give B. B is aromatic. So let's see what is B, A and B are. So with oxidative ozonolysis, what will happen? The bond will get break. Remaining, you are just going to write it as such. So the CH3s are there. Double bond O, double bond O. 2 moles of this must have been formed. That is our A. A is treated with hydrazine. So this 2 oxygens will get, will take up that hydrogen. So which will form, I am writing as such. Okay, these are CH3. And this side I am having oxygen is taken by this H2O, this hydrogen. So remaining I am having nitrogen bonded with nitrogen. Okay, so that's it. That is our B. So select the correct statement regarding the above reaction sequence. This complete reaction sequence involves 4 transition states. So is it right or wrong? This complete sequence is not involving those many transition states. I couldn't see. Ozonolysis involves the hat kind of transition, but not 4 transition states. Step 1, ozonolysis can proceed faster if the methyl groups present in X are replaced by hydrogens. Methyl group will not play any big role over here. Methyl is also a small group, so which is again not the correct statement. One of the key steps in the formation of B is dehydration. That is true, as I told you, plus 2 moles of hydrogen got released. So that is true. And the degree of unsaturation of the reactant organic product B is same as X, and there is a big mistake over here. So the degree of unsaturation of the reactant X is same as the organic product B. So that is our question. So degree of unsaturation of X 2, and here also not 2, overall 3 including the ring. Here also I am having 3. So which need also a correct answer. So D and C and D are our right answers. Let's say this question. 4.2 grams of carbonate of an alkaline earth metal is dissolved in excess of HCl solution, by which 1.12 liter of CO2 at 1 atm and 273 Kelvin is evolved. If the pure metal crystallizes in BCC unit cells, and find out the correct statement regarding the metal. The metal is calcium, metal is magnesium. There are 3 into 10 to the power 23 unit cell. Density of the metal is 1.22 gram per centimeter cube if the edge length of the unit cell is 4 Armstrong. Okay, so let's check out. Let's see what is the reaction happened over there. So I'm taking the metal carbonate with HCl. That is giving us MCl2 CO2 plus H2. So that is our reaction. We'll balancing it to HCl. Okay. So how many? What is the mass? 4.2 grams. So the mole, which will be 4.2 So metal plus for carbonate I am adding 60. Then what tells the information given? 1.12 liters of carbon dioxide. So the moles of carbon dioxide, which is 1.12 by 22.4, which is 0.05. Okay. So these both are equal because 1 moles of metal carbonate gives 1 moles of carbon dioxide. So I am going to put it like this, m plus 60, which is equal to 0.05 equal moles. So m plus 60, which will be 84, and m will come out to be 24. Okay, so if 24 means which is related to our magnesium as atomic mass. Then they are asking about density. So for magnesium we are going to find the density. D is equal to Zm A square Avogadro number, that is our A cube Avogadro number, or volume into Avogadro number. So 2 into 24, 4 into 10 to the power minus 8 cube into 6 into 10 to the power 23 I am taking, which will comes out to be 1.25 gram per centimeter cube. Okay, so in that case the number of unit cells, which is 1.2 by 24 into Na into 1 by 2, right? So they have given BCC, so 1 by 2, so which will comes out to be 1.5 into 10 to the power 22. So let's check out the options also. The metal is magnesium. There are 3 into 10 to the power 22 unit cells in 1.2 grams. That is not true. And the density of the metal, which is 1.2 gram, 25 gram per centimeter cube, if the edge length is 4 Armstrong. That is right. Okay. So answer to this question is B and D. So that's it for today. Let me know what else you are having the confusions or any concept clarification you want before the examination. All the best.